Data importing. It is necessary to inform the year and the municipality to be imported. Year and city. After importing, review and expenditure data from municipalities. You can check the imported bases. Filter configuration. Views by profile. Application filters in the preview.
So, thank you, Cesar. I suppose you finished your presentation. I have to be honest, it was quite difficult for me to follow, let's say, your presentation without a proper oral, let's say, presentation, but I can understand your difficulties in presenting. We know you are coming from Brazil and you are showing now. Okay.
Okay.
Do you want to show us something else on this website? No?
Aqui, that's the application.
Okay, if you want, maybe you can tell us something very short also in your own language. So if it is difficult for you to, we can try to understand a little bit also. No? If you want to talk
I don't have
in
fluent
Portuguese or
English.
in Spanish, yes, we understand it is difficult. You come from Brazil. If you want to add something in Spanish or Portuguese, otherwise, for us, it's...
Eu posso estar falando português?
I don't understand Portuguese, but if you don't if it is difficult for you in English, otherwise for me it's fine. I found actually it was difficult for me to follow your presentation, but I understood more or less what was your point, and that's good for me. Actually, I have only a small remark in my mind. Let's say I did not understand how did you consider privacy, the degree of privacy of data within your model and application. But I find it very useful. I can understand the point. Are there any questions from the public?
Então, I don't understand, you know.
Yeah. I understand it is difficult for you, and I appreciate very much that you presented anyway. So thank you. Thank you.
Thank you.
Thank you. Okay. Okay, let's see if the last... are there any other comments from the colleagues? No? Okay, thank you, Cesar. Let's see if Nuno Soares joined us. Nuno, are you online? No? George Abuzelidze, the first presenter, maybe you joined us. I don't see... we have 2 fellow G-stars with us, and that's good, that's fine. But I don't know if they are presenters. I suppose not. Maybe Valentina from the in-presence room. Do you have any news from?
No.
Okay, so I suppose that George Abuzelidze and Nuno Soares
is not here.
Are not joining us today.
No.
Okay, it's a pity because I was really interested in hearing something about transport and logistics in Georgia. So, but I will read the paper. I saw that the papers were already published. Okay. So I don't think we have other presentations left. Are there any comments from the colleagues online or in the room?
No.
Yeah,
not have any question.
Okay, I really enjoyed the presentation of Claudia Nodari, the first presentation, and I am going to read her paper as well. Okay, so thank you, Claudia. You did not presented yourself very well. Are you a researcher?
Okay, this is okay. My microphone is on. I'm a PhD student at Politecnico di Milano, and I studied this electric method for charging vehicles. this is the first part. So first of all, we studied the structural response. Then we studied some effects on long behavior of pavement. So some fatigue effects or rutting effects. And the part on which I'm working is the implementation of an algorithm to choose the best place in which allocate this charging unit. So your question is okay. I'm
Are
studying
you in which year of your PhD are you?
third.
Third year. Oh, so the last one. So I wish you good luck for the final, for your final efforts. Okay. And I look forward to read your papers on where to locate in our cities your technology. Okay.
Actually, the case study is in Milan. So it's a big city with some not problems, but different yes, different problems. So it's quite difficult, but we are working on this part.
Okay, I can imagine. So I wish you all the best for your final year. Okay. Thank you very much also to Cesar. I will read your paper as well. And if we do not have other questions or comments, I think that we can finish now our session today. Do you agree, Valentina?
Yeah, I agree with you.
Okay, that's perfect. So thank you very much for being here with us today. I wish you a best conference also in presence. It's a pity for me not to be with you in Cagliari, but I won't miss the next opportunity. Thank you very much.
Thank you. Nice to meet you, Silvia. I hope to see earlier.
Okay, thank you.
Bye-bye.
Bye.
Bye.
Alô, alô, testando, testando, alô, alô, testando.
is on.
Giusto, perché è un'altra stanza. Hello?
E tu dove ti siedi qua?
Sì, mi sono ora la vedono?
Sì, perfetto.
Ok. Quando vuole.
Ok, perfetto. Non succede niente. Qual è la sessione qua nostra?
La room di...
Ok, quella lì, perfetto. Benissimo. Perfetto.
non,
Vabbè, non si preoccupi, perché sennò ci cade. Ok, sta registrando?
sì.
Ok. Good. Okay. Welcome everybody to welcome to Cagliari. Now I have a session, the general track session, and I have 4 contributions in this session. And the first contribution is the non-cooperative nuclear density predicted in Vantis, and the second contribution is an University Cagliari contribution, and the third contribution down is the semantic 3D models of Sophia city, and the last contribution is the impact high speed real on the territory accessibility, a comparison among some European countries. Every speaker have about 50 minutes, and after every contribution, I have a time for a question. For the first contribution, who is, please?
Caesar, I'm here.
Okay, you're welcome.
Thank you.
Okay.
Let me share my screen. Everybody can see my screen?
It's okay?
Yes. So thank you very much. I'm very happy to be here and present our paper, Non-Comparative Vehicular Density Prediction in Vans. My name is Cesar Marcondes. I'm from the Institute of Technology of Aeronautics, and my colleagues from Federal University of San Carlos, Lourdes and Hermes. Lourdes is the main author of the paper. I'm a co-author. Unfortunately, she had a baby, and I will present for her. Okay, so let's start with some motivation about our work. So the idea is that today we have more than 3 billion cars running around, and modern intelligent transport systems can really improve safety, efficiency of these modern systems of cars. However, we have lots of problems related to the communication between vehicles. In order to these applications to work, the communications have to be very good, and there's major challenges in communication because of the wireless spectrum due to vehicle density. So the number of vehicles in an area can affect the way the communication works. So, for example, if you send a message broadcast in a high density scenario, it's very difficult. You're going to have errors. And if you are in an area with low density, maybe there's no guarantee that the vehicle will receive a message. So flood is necessary. So our key idea is to do density estimation in a non-comparative way. So different than the other methods that use, for example, no degree, average velocity, speed direction, our idea is to obtain a sort of group stability metric as a long-term metric. Our insight is that groups behave at the specific times and specific places in a certain way. So in order to do this, to accomplish this, our method uses vehicle in cloud, using cloud, to run a machine learning model. And then from this machine learning model, we infer cluster that the car belongs to and a cluster that is stable and has the same behavior. We simulate our method in real taxi traces and replay using epidemic communication patterns. In terms of related work, there's a bunch of work on density estimation algorithms for vehicle networks. Some of them are just based on channel busy ratio, for example, or bit error rate to estimate if you're in a dense area or if you're in a low density area. Also, mobility information. Some of the work presents some graph-based connectivity, like, for example, you can collect the node degree, the number of neighbors that are around you, the link duration. But all these parameters change frequently. And as you get this information and try to find out where is the group, which group are you belong to, certain times it breaks because you're moving. There are other methods that are used, like infrastructure-free and RSU-supported density estimations. Some use statistical models like exponential vehicle inter-arrival times, but this is complicated because the traffic is long tail. Also, roadside units can support the collection and the distribution of information, but doesn't support prediction. And there's some other methods that are cooperative that can use cluster heads. And cluster heads could gather the information of the density around the area of the cluster head. But there's an additional overhead to do this cooperatively and to broadcast this message. So our work focuses on a new trend on vehicle using cloud. This way, we have a real-time layer of predictive capabilities. Oops, sorry. So the main architecture of our method is based on a layered vehicle in cloud structure. In this graphic here, in this picture, we can see that the blue part is the perception layer of this AI-based architecture. In this perception layer, we gather information from the cloud, we gather information from the position system of the vehicles, GPSs, the roadside units transmit this information back to a back end, and this back end sends density parameters to a smart application layer and intelligent layer that would give some rules of how to actuate on this scenario, like how to optimize the communication network, how to optimize authentication, etc. So from these steps, vehicles share the locations using cloud, so it doesn't need to be cooperative. It can be non-cooperative. The cloud processes information and then runs a machine learning solution that uses machine learning rules to estimate if you're in a dense region or if you're in a sparse region, and then using these actuate, like, for example, using a probability method for sending on a dense region or another method to send to a sparse region. The main method that we propose is based on this machine learning on vehicle using cloud to predict groups, how the cars are organized in groups, and in special groups that are stable, groups that don't change with a lot of time. You can predict in ahead where which group the car belongs to. Using this, we can use this grouping prediction to help improve, for example, beaconing, geocaching, unicast, etc. Although the performance is not the focus of our paper, we're validating only the idea that the group is stable, that they are really inferring the stability of the group. So the method is basically we use these density inference rules produced by a trained model. We assume that vehicles can transmit GPS and temporal data to the cloud using road assistant units, or even using a multi-hop transmission. And then we have three major steps on the method. Detection of the group, using some algorithms, some clustering of these groups using hierarchical clustering, and then a train and prediction using a model based on ensemble of random forests. So the first step is to detect the moving groups and isolated nodes. So in order to do this, we use the position and temporal information from the cars, and then we identify the groups that existed before by looking at a snapshot of the positions of the vehicles. So here are some of the description. The snapshot is basically a position of the vehicle in a certain amount of time, all the vehicles, and then we look at these in a window way. So we look at the trajectory of the vehicles. Then we apply some reachability criteria to identify the neighbors within a snapshot, and if the neighbors are directly reachable. And then we use a threshold of a parameter of these snapshots to see if the cars belong to the same group in a certain amount of time. This way, we recognize moving groups from consecutive snapshots. This algorithm is inspired in the DB scan that uses communication between vehicles to find out this reachability criteria. Afterwards, we cluster the groups, and in order to cluster the groups, we use a specific stability criteria. We base the set of features that are the behavior of the cluster, and basically we put together the group of cars based on survival of this cluster. Cluster lifetime is one of the metrics, average number of members of the group, and average time of membership is another information, so that we can hierarchical clustering this using these stability metrics. And using this hierarchical clustering, we have this specific label that we can give to the groups.
Cesar,
this is a group. Sorry?
Cesar, sorry. Can you go to the hand, please? Because I had only 3 minutes. Thank you.
Oh yeah, sure. I'm almost finished.
Nice to be you.
Yeah. So in step 3, we have the train and predictive for the grouped conditions. Basically, our insight that the group motion and the properties are related to specific regions and times of the day. So based on the hierarchical clustering, we label this, and using the label, for example, here's the cluster ID, here's the day, time of the day coordinates. We train a predictor using random forest, an ensemble of random forests. So based on number of day, time of day coordinates, we get the cluster ID. We did the cluster case study using the Rome taxi dataset. And this dataset has 316 taxis with GPS collected. We simulate using the one simulator and epidemic protocol, sending random communication messages. Here's a picture of this dataset. And using our method, we set this to interpolate the movement traces. You can see here this interpolation happening in snapshots. We apply the hierarchical clustering and the random forest to find out which group you are in, the vehicle are in, and the vehicles query this information every 15 seconds. We apply DB scan with some specific parameters in order to find out the neighborhood, and we cluster these metrics based on the stability metrics that we applied. We have some of the results. The results show that we need to cut the hierarchical clustering in 3 groups. And based on these 3 groups, we can see that the parameters of the groups are very good clustered. Like the lifetime here of the group 1, group 2, and group 3 are very separated. The average time of membership and the number of members of the groups are very separated. And finally, we did some simulation and the validation of the results, where we present some of the information that are usually shared among the group, like, for example, the average node degree or the number of packets that are transmitted during a certain period of the time. So we can see that there's some separation of the groups that show that they belong to the same group, and so that our prediction is really good. For conclusion, so we devise a density estimation algorithm that adapts the communication in complex scenario. The density estimation is independent of the vehicle-to-vehicle communication. We categorize the vehicle density according to these long-term stability metrics. We use only vehicle location and time, and we provide extensive simulations based on real traces that show that the algorithm improves, and we can later put that in the performance evaluations. Thank you very much.
Okay, thank you, Cesar. Thank you for your presentation. It's a very interesting method, your proposal and this contribution. Any question in the room or remote room? Colleague? Okay, I was in a question for you, but you, in the last slide you did. And what are your future activity? In the last slide you called before, but what you in specific part? Which part you are in the future activity? Because I have a more
Interactive.
part.
Sorry, I didn't get. So the basically, as we predict the groups, we use this information of the predictions of the predicted groups, and then we get to the baseline data from the simulator, the ground truth, and from the ground truth, we get the statistics of, for example, throughput, the time between the connections of the vehicles, in order to show that they experience the same behavior within the group. So this way, we can show that the predictions show that the groups are consistent with these clustered features.
Okay, thank you very much. Congratulations for all authors. Okay, now I have the second presentation, and speaks Professor Boruso. Please, come here.
Do you have your presentation up and right? Yes.
Okay.
Is this?
Valletto Boruso, sì.
Ok. Dovrebbe andare.
Ok. Dove
Ok.
sto? Yes, okay. 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 Good morning, everybody. Thank you. Thank you, Professor Balletto. This presentation is about a paper that we produced together with, Professor Ginevra Balletto, with my name, Alessandra Milesi and Marlado, they are here, and Professor Beniamino Morgante. The paper that we approach here takes its origin from the COVID-19 outbreak, actually, and its possible consequences on the actions that can be taken by different territorial levels. The idea is that, particularly with reference to the Italian case, in which in previous research, we actually observed and demonstrated that the pattern drawn by the outbreak could be particularly studied at provincial level with reference to the different impacts that it had in terms of contagions and death cases. But the actions taken have been particularly from the regional point of view, therefore from another dimension. We actually observed that, particularly in the Italian case, in which we have the case of 21 regional units, more than 100 provincial levels, and nearly 8,000 municipalities. The intermediate level of province units was the most practical to study the phenomenon, but also with the differences mostly observable. While all the political actions taken during the COVID-19 outbreaks and in the post-pandemic period have been taken at regional level, usually considering them as fixed blocks of homogeneous aspects. Here we can observe results from a previous study in which we did observe the standardized mortality ratio, particularly during the first outbreak of the first wave of COVID-19 in Italy, in which we did observe that the major effect did not cover the regional subdivision that are the dashed lines, but we could find clusters more easily detectable from the provincial point of view. That led us to think about a proposal in terms of planning actions to be taken at provincial level. But it's something that in Italy, in particular, did not meet the reality, as the administrative units in Italy has been revised, but not. But this process of revision was not completed. Here we can find a representation of the supra-municipal and sub-regional administrative division, where we can find actually how the situation is fragmented. We have the metropolitan cities that are just a limited number of the major metropolitan areas in Italy, where we have some planning tools, planning instruments that are stronger than in other intermediate cases. We have autonomous provinces that act as regions. We have some region in which provinces have been completely dismantled, and in other cases, provinces do not have a well-defined role in the Italian planning system. What actually pushed us to think was to a possible new role or a new role of provinces in tackling a phenomenon that can be more easily tackled at provincial level. In particular, what we did in this research was to consider the main aims of the National Recovery and Resilience Plan, Next Generation Italy, developed just after the COVID-19 outbreak, and to put the different missions and components of this plan into the provincial level, and particularly into the metropolitan cities level. In this slide, you can observe how the different 6 missions, digitalization and innovation, green revolution, energy transition, infrastructure, education and research, social inclusion, and health, are actually elements that can be considered into a provincial framework. This, in particular, can be studied throughout the main provinces, actually, as the metropolitan cities. Metropolitan cities have been introduced in Italy in the most recent years, and actually gather major cities and combinations of cities. Metropolitan cities are have to present strategic plans in which actually they put together different actions to be taken over the territory, and covering the different municipalities belonging to the metropolitan cities. You can observe here the progress of the strategic plans that need to be actually updated every 3 years, and more or less half of the metropolitan cities have their strategic plan approved, while in most of the cases the strategic plans are still in progress and need to be still defined. What we propose here, what is the main idea in this research, is actually to propose a method to put together the different plans at the different levels of planning at the different levels, regional, provincial, metropolitan city, and municipal level, in order to glue together these different plans, these different times in which the plans become operational, and in order to stick together the different deadlines. Here we have got the representation of the method that we propose, in which we put together the existing plans and frameworks, and we can observe the territorial level, the international, the national one, the regional one, the intermediate one, that is the level on which we are focusing at the present, and the municipal one. At present, we have this kind of paradox that the weakest, at the weakest level in terms of instruments and the force of this instrument is the intermediate level. That is actually the that kind of intermediate and well-balanced level where actually actions could take place with in a more effective way, because decisions are actually taken particularly at national and regional level, while operationally are the municipalities that take actions in a given smaller size territory. So the idea is actually to use provincial plans and metropolitan strategic plan as a gluing element between the national and regional levels and the local municipal level. Next generation at European and national level must be inserted into the sector plans, and using the provincial plan or the metropolitan strategic plan to be then delivered into the important instruments as the municipal urban plan and the single documents of programming. As you can observe, these plans have different durations: 10 years, the next generation, 10 years also at the sector plans, variable times for the metropolitan strategic plans and the provincial plans, and 5 to 10 years at municipal level. The main idea is that in doing that, we can act actually on the public works plan to as an instrument to implement the actions that are ideally taken at a supranational, the national level, and put into action at the more at the more local level as the municipal one. So the basic idea is that as it is actually foreseen by the Council of State in its sentence of 15 October 2020, supra-municipal planning is characterized by a mixed nature and flexibility in relation with the instruments below. Municipal planning presents an articulation in acts at a general planning that has its objective the socio-economic development of the entire context. So the idea is to use the provincial plans and the metropolitan cities strategic plans as a leverage for actually fostering the actions at local level from the indications that come from the national and international one. I don't know if the chairperson has the need to add something to this presentation. Otherwise, I will stop here.
Thank you very much.
Thank you.
You explained very well our ideas. And I have a question just after we go to the contribution. Behind the principal and the metropolitan city dimension, do you think that there are very maybe other intermediate dimensions?
Well,
metropolitan city province.
Live streaming.
It's okay now? Okay.
okay.
Okay. One moment. Okay. There's a problem on Jitsi.
Mm-hmm. Well, there's a point that, okay, we actually highlighted how, well, we must say that at present, what is the situation of the metropolitan cities, at least in Italy, do not represent functional organization of municipalities, but it is just an administrative translation of the previously defined provinces that not necessarily cover aspects of local labor systems or commuting or other functional organizations of the territory in terms of production or services. This is particularly evident when we consider an example like Milan, in which the metropolitan city of Milan just cover the extent of the previous province of Milan, but it doesn't represent the metropolitan area of Milan, but actually covers a wider set of provinces, also belonging to different regions. So it was different in the case of the metropolitan city of Cagliari, in which the effort in the reorganization of the intermediate level of administration actually led to an organization of the municipalities actually belonging to the metropolitan city of Cagliari, a more functional idea and background. That is to say that we are considering cities, metropolitan cities of different dimension and role, and therefore, within this framework of the intermediate level of the administration, we could think in both terms. On one side, on where it is needed on a revision of the borders of the metropolitan cities, but this is quite difficult, as they are generally defined from an administrative point of view and are quite fixed. On the other side, we could think about an organization of consortium between provinces where this can be needed in terms of the dimension of a certain area, like that could be to my knowledge just the case of the Milano area. Okay.
Okay. Only 2 minutes because I have a technical problem. Only 2 minutes. Okay.
Thanks.
I'm sorry. Praticamente non vedo più la schermata della stanza qui, però se vado a collegarmi adesso sul GC Room è come se avessi doppia camera aperta e quindi mi dà il rimbombo.
Perché c'è questa aperta.
Ah, ok, va bene. Quindi qualora dovessi abbassare, dovessi sparire la carica da qua.
È su Chrome.
Ah, ok.
A posto?
A posto, grazie mille. Ok, we can start. Allora, your presentation is this? Yes. Okay, 1 minute.
Can I remove the mask in order to speak?
If you want. Okay, 2 minutes. And I prepare you. Okay. Un po', giro. Okay,
this is previous one.
Is the previous?
Yes.
This is yours.
Yes.
Okay. So. Okay.
Thank you. Hello, my name is Desislava Petrova. I'm associate professor at Faculty of Mathematics and Informatics in Sofia University, and also research group lead at Gate Institute, which was found before 2 years within a project funded by Horizon 2020. So I'm going to present a paper titled Towards a Semantic 3D Model of Sofia City, and the work is part of our project for development of city digital twin of Sofia. Here you can see our goals within the project. The first goal is to produce a high-quality 3D information model of Sofia City, starting from part of it. Next, to semantically enrich the 3D model by sharing with institute stakeholders. And the next goal is to apply the 3D model for simulation, analysis, and visualization of urban environment and processes. And finally, to promote the exploitation of the digital twin between stakeholders. The area under modeling covered district Wozenets in Sofia. It is 9.24 square kilometers. Two small rivers flow through the territory, and almost 30% of this area is covered by forests. So we have different kind of city objects that could be modeled. Now I'm going to present the technological stack used for implementation of the model. We have three main data sources. The first one is cadastral data, which covers objects like buildings,
Sorry, we cannot see your presentation. I mean, you haven't shared the screen. We cannot see that, sorry.
There is a technical problem.
But, okay. Okay. One minute. Can you see now? Are you hear me? Are you hear me?
Yes, I can. And now I can see your presentation. Thanks.
Okay. Okay.
So this was the area that we've modeled. It is district Wozenets of Sofia City. And now I'm continuing with the technological stack where we have three main data sources. First, cadastral data, storing information about the buildings, green spaces, water bodies, relief, etc. Also, we have point cloud data which cover the area, and satellite images. These two data sources we use to enrich the 3D model. The model is built following the CityGML 2.0 standard, and it is imported in 3D database, which is created over PostGIS database. We are also working on development of domain-specific data models and ontologies, and perform some experiments with graph databases such as Neo4j. So the 3D model is hosted on a Cesium Mayan platform, which serves the model in the cloud and provides streaming. We've developed a web application for visualization of the 3D model using Cesium JS library, and the web application is hosted on Node.js server. The model is used in different use cases. The first use case is related to parametric urban planning, where we perform design and planning of a single neighborhood based on preliminary defined indicators, regulations, rules that we obtained from the municipality. Also, we are working on air pollution simulation. Here we perform computational fluid dynamics simulations. And when we have next level of detail of the model, because the current model represents the buildings like cubes, and on the next level we have rooftops. And when we add this information to the model, we can perform solar potential analysis, for example. And here you can see the input data. We have buildings in shape files. The shape files contain the geometry of the footprints of the buildings, like polygons, and also additional attributes like number of walls above the ground, also function of the building, etc. Also, we have a data set with addresses of the buildings, and also two TIFF files with the digital terrain model and digital surface model. The model is developed using FME software. It is ETL tool. Here you can see the workbench for the modeling of the terrain. And this workbench is split in two parts. The first one produces the relief object in CTGML format. And the next is used for generation of CSV file with points needed to interpolate the building footprints on the terrain. So we are looking for terrain intersection curve. This is needed because due to this situation that we see here, there are buildings that could be sink on the terrain or fall over the terrain. So we need to put the buildings on top of the terrain. And here steps for doing it are explained. First, we take a polygon and calculate its center. Next, extract all vertices in 300-meter radius for that center. Generate a grid from the vertex points with a 2-meter width. Create an interpolation area from vertices. Divide the polygon into its points and allocate height for each point separately. And finally, we have 3 new attributes for the buildings: minimum, maximum, and mean elevation of the building footprint. Regarding the addresses, we perform a mapping between the buildings and their addresses. And difficulties here were that some address points falling outside of the polygon. So we need to connect the buildings and addresses and to assign address attribute to each building. And on the next step, we perform some refinement of the 3D model. Here you can see one of the highest buildings in the area. This is a hotel. When we obtain the data from the cadastre, we have one polygon that is represented on the left, but the building itself has 2 parts, and the highest part is obtained from OpenStreetMap data, and then we create the building of the hotel by combination of 2 parts. And finally, the buildings are extruded based on the number of the floors. So each floor is approximately 3 meters, and then we calculated the height of the buildings on this way. And here you can see the FME workflow that is developed for construction of the buildings. And the final result is presented here. You can see how the terrain and also the buildings objects are represented. And here you can see the web application which visualizes the buildings. It provides functionality for highlighting the building and representing its attributes like function, also to filter the buildings according their class, latitude or height. Also, there is functionality for representation of shadows depending on the current time, and filtering of buildings that are higher over 50 meters. And this brings me to the end of my presentation. At future work, we are planning to transform the model in CTGML 3.0 standard. I hope that the standard will be launched soon. It is under development. In the new version, there is opportunity to integrate time series data, for example, IoT data. Also, it supports versioning of the city models and integration with point cloud data. And one of the benefits is development of conceptual model standard, and next separate encoding standards which could be connected to the conceptual model. Thank you for your attention.
Thank you very much for your presentation. Technical proposal. Any question?
Yes.
Actually, we have new results for a single neighborhood where we modeled also the green spaces and road infrastructure, but this will be explained in the next paper.
Thank you very much.
Yeah.
Congratulations to you. And
thank you. Okay.
And for note room, there is a question.
Okay. There is a question? No, maybe not.
Okay, thank you very much. And the last presentation is here or not that? Okay, that's okay. Thank you very much. You have 50 minutes to present.
Can you see my screen?
Yes.
Okay, thank you so much.
Okay.
So, good morning to everybody. It's a real pleasure to be part of this very exciting session. My contribution is mainly related to the transportation systems, being a transportation systems engineer. So, this is the outline of my presentation, and I will go immediately to the background and the objectives. High-speed rail systems will be one of the keywords of this presentation. The reason why many countries are now investing in high-speed rail systems, it is not only because these systems provide green transport alternatives or provide or increase the transport infrastructure capacity, but mainly because they promote economic growth and regional development, thanks to the increased accessibility that these systems provide. So the other key word of this presentation is accessibility. In Europe, we can define three different models of high-speed rail systems, the French, the German, and Italian models. Well, the first one is mainly related to newly built lines dedicated to passengers with speeds up to 300 kilometers per hour. The German model is, for freight and passengers as well, and is conceived for, renewing existing lines with speeds lower than the French model. And then we have the Italian model, which is conceived on the French model, but it's also for high-speed, high-capacity freight. Well, indeed, this presentation will be on the high-speed rail systems impacts, and in the literature, the wider socioeconomic impacts of high-speed rail systems have been widely treated. The competition with other transport alternatives, the modal shift from car to high-speed rail or to plane, to high-speed rail, the socioeconomic impacts in terms of location, relocation of residents and jobs. For example, after the introduction of a new high-speed rail line, the implications on the tourist market or, on productivity or the GDP of a country. And of course, the environmental impacts is also another related issue. High-speed rail systems are greener transport alternatives with respect to other transport alternatives. The objective here is to evaluate how high-speed rail systems improve accessibility in given countries. Indeed, the case studies are 4 case studies. Spain, where the first high-speed rail line was inaugurated in 1992 with the Madrid-Seville. Then France, the first line was the Paris-Lyon in 1981. Then Germany has a mix, it is not built or conceived on new lines, but dedicated to passengers, but is for freight as well. And the first line was the Hanover-Würzburg in 1991. And then, of course, Italy could not miss in the list, should be there. The first line was built connecting Rome with Florence in 2008. For these countries, what I did was to start with the zoning systems of these countries that, of course, they change, they vary, considering in provinces, districts, federal states, etc. What I did was to collect information from different sources about the travel times connecting each OD pair. So what I did was to take 2 pictures, one of the travel times in the year 2000 and one of the travel times in the year 2018, and comparing these 2 images, these 2 pictures of travel times, in 2 different moments during the evolution and the evolvement of the high-speed rail systems. Another data that I collect was the interchanges between, the different OD pairs in the year 2018. Another information for each of the pair that I needed to collect was, the average second-class fare, which was estimated taking into account the last year of analysis, the year 2018, with a discount rate proportional to the GDP growth in the different countries. So how did I compute the accessibility due to high-speed rail? Well, what is accessibility? It is exactly the link between the transportation system and the activity system. And then we have an active accessibility and a passive accessibility. The active accessibility is the ease with which from one zone you can reach the other zones with a given transport alternative mode. And the passive accessibility is the ease with which one zone can be reached from the others. There are many measures, indicators of accessibility in the literature. Normally, they are a function of, an impedance function and then an attractiveness function. The one I've chosen here for this study is the one reported here, which is an active accessibility related to the origin zone or to all the study areas, and is given by the difference of the generalized travel cost between a given OD pair with the fastest rail mode, and then the attractiveness measure is the number of jobs in a given zone. So the generalized travel time is given by this measure, where VOT for transportation engineers is fundamental, is the value of time equal to the monetary value associated to the time spent for traveling, and the values for the 4 countries are provided by the European Commission guidelines, which are public. You can download from the website these values. So what I got is that, considering the 2 pictures, 2000, 2018, and evaluating the difference, you see that there is a reduction in travel times, for each OD pairs. You see the average with and without high-speed rail. And you can see that high-speed rail definitely brings an increase of accessibility due to a decrease of travel times. And you can see from this image, from this picture, that this is confirmed. You can see these are just the values reported, in picture, the previous values. So what are the results? The results are consistent with some, previous studies related to this issue, it is true that high-speed systems actually bring, increase of accessibility. The answer for these 4 countries is yes, and it's, perfectly in line, consistent with other studies present in the literature. So I'll go immediately to the conclusions. I've been very short. Yes, it is probably obvious to say, yes, of course, high-speed systems bring accessibility, and definitely they improve the economic growth between, the cities served, because, increasing, and facilitating the movement between and each of the pair, it increases commuting flows, and definitely this has an impact on the productivity and the GDP of a country, also in terms of tourism. One issue that will be probably, my further, well, it is already my current study, my current interest, but it will be the more and more my future interest, is the question that high-speed systems, yes, they increase accessibility, but definitely it is not obvious that they increase equity. From recent studies that I have come across into, the equity, the inclusion term and issue is really a problem in terms of the fact that, high-speed systems are still conceived for business travelers. So they are not inclusive systems. From recent surveys I came across into, this is not fair. I mean, you cannot introduce a large infrastructure such as these ones that are costly, extremely expensive, excluding a priori some socioeconomic categories. We really need to fight against this. And the other issue is that these systems are not capillary. They don't serve all the parts of the country. Italy is completely abandoned in the south, is completely abandoned. Something will happen with Naples, Bari, high-capacity, high-speed system. But how about the south? I've learned that there are some, studies starting working on the Salerno-Reggio Calabria high-speed rail line. So again, the inclusion question will be my, next step. Thank you for your attention. Hello? Hello?
Sì, hello. Thank you. Thank you very much, Francesca, for your presentation about impact on accessibility and commuting time into the longer net and in the principal country in European countries. It's very interesting. And now I ask any question, please. And Professor Bordo, come here, please. And after I have one for you. Thank you.
Okay.
Hello, Francesca. Thank you for your presentation. I got a question for you concerning the...
I cannot see you. Is it possible to see your face? I mean, I can...
Okay.
Okay, now I see you. Ciao.
Ciao, Francesca. Hello.
Hello.
Thank you for your presentation. Just a question. Do you think that evolution in terms of the high-speed railways in Europe, but particularly in Italy, are considered so strategic at present? Because as we also observed both in the PNRR in Italy, which is actually funding some routes, some missing links in the high-speed network in Italy, and some decision taken by other countries. Let's think about the United Kingdom that actually decided to not to foster with so much strength the national high-speed network. Do you think that there is still a future for such huge investment in high-speed railways, particularly considering new branches, or governments are quite happy in one sense with what they have in terms of the existing infrastructure, and maybe searching for alternative solutions for the other not so gravity intensive destinations? I mean, this is particularly for the case because we know in the northeast of Italy, but southern Italy is quite similar, that there is not that much interest in connecting areas that are either weaker in economical terms or with not so much potential demand exploited.
Okay, so what can I say? You are asking this question to a high-speed rail supporter. So, of course, the answer will be yes, in the sense that, of course, post-COVID-19 will have other priorities. But, of course, the transportation system investments is one of the priorities in terms of improving, connections between parts of countries. And, well, you were highlighting the question of Italy. Improving the south of Italy with more connections, if you put, it's true, you insert a new link if there is demand. If there is no demand, it's, a new link is not useful. You are right. But, sometimes it happens the reverse impact, in the sense that if there is an infrastructure, people will use it. So, in terms of this, I'm confident that rail is always one of the most preferred transport alternative in terms of, for example, energy savings. With respect to cars, rail is 4 times more efficient with respect to car. And with respect to plane, is rail more efficient 9 times with respect to plane. And how about the environmental impacts, with respect to cars or other alternative transport modes? In terms of, green gas emissions, it is less pollutant. The aspects of environment and, of course, of energy savings are really important aspects to deal with. I know that transport economists are against our high-speed rail systems investments. I know this, but they deal with these systems in any case, and I've learned that some are changing their mind, especially considering other investments that they are doing in magnetic levitation and hyperloop. I'm sure that you have heard about them, and they are absolutely risky and with many healthy problems. So I'm quite confident that post-COVID-19, in the new normal,